Okay, for today we'll do a little bit of a review of logs, and we're going to start here by just talking about these. Those are whats of each other. Starts with an I. Inverses. And the red one and the dark blue one there, they're a reflection across that line y equals x. So they're kind of related to each other. All right, exponential decay would look like that. Why is it always forced to go through that spot when it's exponentials? Because x equals 0 right here. And if you think about it, if x equals 0, do you get how you have a to the 0, which means it's got to be 1? Anything to the power of 0 has to be 1. That's why it's going to go through 1 there. So even if the base is like 1/2, anything to the 0 has to equal 1. That's why it always goes through 1. So if x equals 0, it's going to equal 1. Now, can I move this up or down? Yeah, I can just add 6 out here and the whole thing has to move up. But in its natural form, it would always go through that spot. And why do logs always go through this spot? Because x equals 1 there. And if you have a 1 in the argument, what do you get? 0. So it's got to be 1 comma 0. Because when you put in a 1, you have a 1 in the argument. And it's 1 in the argument gets you nothing. All right, some of those little patterns are super important. So we're going to do a speed round here. You're supposed to know these like boom, boom. So if I say log base 3 of 3, you're supposed to know the answer. What is it? 1. Good. All right. How about log base 3 of 3 to the 4th?
4.
Then it's 4. Because if these two are the same, then the answer is the exponent on the argument. Next, you don't know this yet, but this goes out to the front. I want you to think that through. If the answer is 4, do you agree the answer is 4?
Yes.
Then do you get log base 3 of 3 would have been 1, and then 4 times that is 4, so it works. So this is kind of a mind blower. You can take the exponent that's on the argument and just move it down to the front like that. Yes, you can do that.
If they're the same.
No. If it's there at all. If I had log base 7 of 7 to the 8th, the 8 can go down in the front.
Well, I mean, if it's 7 or 3 and 3.
Oh, if the bases are the same. Yes, if the bases are the same, then you can take that number and move it down to the front. In fact, even if the bases aren't the same, you can do it. It's not as easy to see that the answer is the same, but it is. So even if these were different numbers, this power gets to go down there anytime it wants to. And it's easy to tell this one because what's log base 7 of 7? It's 1. What's 1 times 8? It's 8. So you can tell you're going to get the same answer. Because normally our answer is just whatever the power is there. Okay. So what if I had log base 3 of -1? What's that answer? You can't have that. There is no answer for that. Why? Because you're not allowed to have negative numbers here. It's just like you're not allowed to have a 0 on the bottom of a fraction. Can't do that. Okay, can't have negative numbers there. Can't have negative numbers here either. You also can't have 0 in either of those two spots. All right. So, a quick reminder of how to graph logs. Well, if I say log base 2 of x, and I ask you to graph that, you would immediately, I hope, make an XY chart and find a few things. What would be a smart number to put in for x? 1 is always good because if you won the argument, you get nothing. 2 works well in this case because it matches the base. And then what's the answer then if I put in a 2? 1. And let's get a couple more. 4 would be smart. Why? Because it's the same as 2 squared. And then really you've got log base 2 of 2 squared. So you put in a 4 and you get 2. And one last one. This is log base 2 of x. if I put in an 8 here, I like it. Think about it for a second, everybody. Don't say it. Think about why he would choose 8. It's not because it's 4 times 2. When I put in an 8, I get, well, that, yes?
Because it's 2 to the third.
Is 2 to the third. And then I've got the bases of the same. So what's the answer? Okay. Now I did that one for you. And you got help from classmates on that one. So I want everybody to try this. What's log base 5 of x got for points? I want you to find, how about find this? Find 3 points and the asymptote. That's a reasonable amount. We sometimes ask you for 4 points, but you really only need 3 to see a curve. And the asymptote definitely helps. If you can do this, this is the base level of graphing. Sure, you could make it more complicated by putting a number in front or something, but all right, I would like you, if you haven't already, I'd like you to put in the point 1/5. Why would that be smart? Because then a 1/5 goes here, and then you can think through, oh, that's really 5 to this power. And then, so if you haven't done 1/5, it's surprisingly easy to do. So add that to your list of points. Okay, now compare with the kid sitting next to you and see what they think. Compare points. Okay, Val, can you tell me what you got when you put in 1/5 for the x? Because this really is 5 to the -1. And then your answer is always the power. Okay, just clarifying for those that may not understand that at home. All right, what's the next one you put in? Val?
I did 5.
5 gave you what?
1.
And keep going.
25.
25 gave you,
2.
I like it. Did you find the asymptote?
No.
Okay, learn how to do this, everybody. Whatever makes the argument 0. And you might be saying, but you can't have a 0 there. Exactly. Whatever makes the argument 0, right there, that gives you the asymptote. There's a lot of things that fail. You could put in -6, you could put in -22. But whatever makes that part 0 is where the asymptote will be. Okay, what asymptote? Well, remember what logs look like? A base log has a line running right there, and it goes like that. That's kind of what the parent looks like. There's always an asymptote running up and down at 0. But you can be moved. So, one more time. I think this would have been the most missed question. Log base 6 of x minus 4 in parentheses. What would be the asymptote for this one? Four. Why? Because it makes this part equal 0. And what equals 4? X equals 4 would be the asymptote. So this seems like I'm saying to move the asymptote over to x equals 4. And it makes sense if you think about it. Doesn't that mean move to the right 4? So it makes sense that the asymptote would be at 4. Okay. Then that was logs. How about exponentials? What if I asked you to graph y equals 5 to the x? Is that an exponential? Is it an exponential? Yeah. How about what if I said y equals e to the x? Is that an exponential? What's e about? 2.7-ish. 2.718 to be more exact. And if you're going to round 2.7, would you agree it's about 3? 3-ish, okay? So this is kind of like graphing y equals 3 to the x. All right, and how about if I asked you to graph this? Y equals 1/2 to the x. Is that exponential? Yes. Is it exponential growth? No. That one would be exponential decay. Why? Because it's got a small number. You're taking half times half times half times half. It's going to get smaller, 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 smaller. Okay. All right, so what if we did say this one, I want to know some points? You'd make an XY chart. Be pretty easy. Give me some logical things to put in, Aiden. X equals what? Aiden?
Some logical things for y.
For this. What should I put in here?
Do 0.
Okay, put in 0, and 5 to the 0 is 1. And then what else could I put in?
You could put in 1.
1. 5, good.
2, 25.
2, 25. Now my numbers are getting pretty big. You realistically wouldn't be able to graph that one, so let's go the other way.
-1, 1/5.
Yes. All right, I think you got the idea. Just to stretch you a little bit, everybody put in -2. And remember what that means. 5 to the -2. What would that be? I always like to think of that as 5 squared, except it can't be really 25. It's 1 over 25. So I always think of these negative exponents as two parts. There's the squaring part, and then there's the flipping part. So it's 5 squared, and then you flip it, 1 over 25. Okay, and if as long as you can graph points, that's pretty easy. All right, on an exponential graph, they look like this. Where's the asymptote on an exponential graph? Yeah. Would that ever change? Only if you took your graph, which was like y equals 5 to the x, and then how could you make it equal 0 somehow? You'd have to do something on the outside out here. Do you get I could move my asymptote by saying, I want to move it down 3, -3. The whole thing moves down 3. Asymptote has to move down 3 also. That's the only way to move the asymptote, though. Because otherwise, you'd be saying that somehow you could make the answer come out to 0. How can you make that turn into a 0? You can't. Unless you put something on the outside. As long as that's not there, you can't make 5 to the x turn into 0. It's kind of a brain bender a little bit. A lot of people think that, well, if you put the right thing in for x, it'll turn into 0. Nope. That's why there's an asymptote there. Okay. All right. I feel like you're in a better place there. Let's find out if this actually works. Did I teach you well enough how to do inverses yesterday? I don't think so. So I'm going to take a minute and just talk inverses again. If I wanted to make this into an inverse, the first thing I'd do is change that to a y. Isn't f of x the same as y? Not a trick question here. Isn't f of x pretty much the same thing as y? Okay, good. Then don't you switch x and y? To get an inverse, that's what you do. 3 to the y plus 2 minus 4. And now you just have to solve it. And big surprise, logs are involved, given the chapter we're in, right? So if I'm going to solve this, what am I solving it for? If I was solving it for x, I'd be done already. So what do you think I'm solving for? Why?
Wait, why do you write 3 to the y plus 2?
Because look right here. See how it used to be x? Now I changed it to y. And see how this used to be y right here? I changed it to x. X and y are switching because why? Because we're finding an inverse. I'm glad you asked. When you're doing an inverse, that's what happens. X becomes y and y becomes x. I don't know if you remember this unit from earlier this year, but we found inverses earlier this year. Now it's just about solving for y. I'm going to circle this. That's what I want alone, right there. In the order of operations thing, remember, you're solving an equation, you go PEMDAS, except backwards. You look at seeing, can I add or subtract anything? Yes. What could I add or subtract here that would make life a little better? All right, let's add 4. And I have x plus 4 equals 3 to the y plus 2. And now you would be stuck with any standard thing. If you decided, like, I'd like to multiply both sides by this, or, you know, it won't work. Because this is what we have logs for. Anytime you have something in the exponent that's causing you trouble, it's log time. Okay, so now I rewrite this as a log. Log, and what is the base in this question? Log base 3. And then do you just go in order? No, you jump around. You go to this side, x plus 4. And I'd prefer that in parentheses, but as long as we just go right to the equals, it'd probably be okay. Equals, jump back around, y plus 2. And that's not a y, this is a 4 right here, just to clarify. Here, I'm going to make this a better 4. And that equals y plus 2. Do you get it's really close to being solved now? I just have to subtract 2. And y will be alone. And that's finding an inverse involving logs. So final answer, subtract 2 here and subtract 2 here. But I got to be careful. Remember, this is part of the argument. It'd be really easy to just think, oh, I'll just subtract 2 from the 4. No, no, no. It's log base 3 of x plus 4 in parentheses. That was all as a group. That x and that 4 were in a group. And now I'm going to subtract 2 at the end. Minus 2. There is the inverse. Okay, let's see if you can do one. Everybody take... actually, you know what? I'm going to rewrite one like that. Let's try that one. Find the inverse. Good luck. Okay, see if you started right. Should have been x equals 1/2 to the y plus 7 minus 5. That's me switching x and y. You know, like this x becomes y, this y becomes x. Okay, now I'm going to add 5 to both sides. X plus 5 equals 1/2 to the y plus 7. Then, when you're stuck, and this is a good piece of advice, listen, when you're stuck this unit, consider rewriting it. The rewrite is where you go from a log to an exponential or an exponential to a log. I did say on day 1 that whenever the secret to the logs is that you got to just be able to go back and forth between the two things. Okay, so this is where you'd go log. There isn't any log, so I'm going to introduce a log. Log base 1/2. And then I got to go to the other side of x plus 5. I'm putting it in parentheses. Equals y plus 7. Then if I just want to subtract 7 from both sides and do it kind of a sneaky way, I'll just make this disappear and put this as a minus 7. And there's my answer. Raise your hand if you had that one right. Okay, if you didn't, then just hopefully you saw where you made your mistake. All right. So that one doesn't have a base. So what is the base? 10. What is log base 10 of 100? Nice. You did that really quick. Really isn't 110 squared, and so isn't he right? It's 2. That make sense? Okay. How about this? This becomes 3 to the negative third. First you think, how do I make a 3 into a 27? 3 to the third. And then you make it negative. 1 over 27. Okay, so this changes to that. And then any of you, once you got this far, would be like, duh, these bases are the same. The answer must be negative 3. Okay. Now, this is the part where we're doing this part today. I had explained all these other properties, and I want to just go over them real quick. If there's a 0 there, there's no answer. In fact, if there's a 0 there, you've found the asymptote. So this is even better than no answer. It's the asymptote. This one, bases are the same. The answer's already there. The answer's x. I did that one on the first day. We haven't talked about it since, but that'd be like 5 to the power of log base 5. And anytime you see two of the same number, you should be suspicious that something's going on. If these are the same, the answer's already there. The answer's 8. You won the argument. What do you get? Nothing. These two are the same. The answer's the exponent, which in that case is a 1. And this one I haven't talked about either, and I'm going to talk about it briefly. It's called base change, this one right here. It's really confusing to look at, but let me explain what it's doing. If I said I had log base 3 of 7, I can change this to any base I want. What base does it have right this second? 3. I can go log 3 oh, nope, I just did it backwards. You'd think the first one would be on top, but it's not. Log 7 over log 3. And that is how you could put this in the calculator and get the answer. Log base 3 of 7 is the same as log 7 over log 3. Do you get to have a calculator which has a button that says log on it? What base would that naturally be? Base 10. So I have now changed this to a base 10. I didn't write the base because I didn't want to annoy you with extra little 10s, but do you get that that's now a base 10 problem, the one I wrote in black? Why would changing to base 10 be handy? Because you could put it in the calculator. If you have your graphing calculator, let's do one like this. It's going to be slightly different. I'm going to start with this. 5 to the x equals 8. We did this on day 1, and I said, well, we can do this with logs. And then you're smart enough now to know that's log base 5 of 8. So let's put in log base 5 of 8. But how would you put it in? Log 8 over log 5. I strongly recommend you put parentheses around this, or you might by accident not actually divide these two. You might actually end up doing log 8 divided by log 5 all on the inside. So whenever you have a big fraction, smart to put parentheses around like this. Okay, give that a shot. Use your calculator. If you get an answer like 1 point something, you're on the right track. Because remember what this is. 5 to the what equals 8. And the answer is like 1 point something. Pausing for a second. And now, either use your iPad or your graphing calculator, and you type in log 8 divided by log 5, and you get 1 point. What did you get?
1.292029.
Good enough. And then we can round eventually, right? Because we know this goes on for a long time. In fact, forever, and never repeats. Okay, so anyway, that irrational number could be rounded about 1.3. What does that mean? That means 5 to the 1.3 approximately is 8. That's the point of this. Now, what if it isn't 8? What if it's like 7.99? It's because we rounded it. You know what I mean? It won't be exactly 8 unless we use exactly the right answer. So when we round to 1.3, 5 to the 1.3 isn't quite 8, but it's really close. Okay, now this part is important. I know you liked to use log 8 and log 5 because you have a button called log. What's another classic log button, but it doesn't say log? Yes?
It doesn't say.
It doesn't say log. Yes? The ln button. Everybody just try this. ln 8 over ln 5. And weirdly, it'll still work. Now, if you're using the iPad, do you have an ln? You do have an ln button. Okay. All right. Did you still get 1.29, blah, 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 blah? Okay. What does that tell you about the base? In this case, it was base 10. In this case, it was base e, because log base e is the same as ln. What it tells you is that the base doesn't matter as long as it's the same. We did it with log base 10, so we got the same exact answer as if we did it with log base e's. Same exact answer. So I'm here to tell you, you can make this into log base anything as long as they're the same. Those could be 17s if you wanted it to be. So this is called the base change property of logs. So if I have log base 4 of 12, and I don't want it to be base 4. What if I want it to be base 10? That one's easy. Log 12 over log 4. But the thing that really messes with your head is that this could be anything. Log base 4.2. Log base 4.2. It doesn't matter what the base is because it'll keep the same ratio. Okay, it keeps the same ratio. Do you get, if you take a tall person and you measure their hands, how big their hands are, and you take a shorter person and measure how big their hands are, usually the ratio stays the same. The proportion kind of stays the same. Wouldn't it be silly looking if you had like 7 foot tall guy with tiny hands, like your size hands? It would look ridiculous if you had a 7 foot tall person with like 5 foot tall person hands. Okay, so it's proportional. So as long as you keep the same base on the top and the bottom, it'll work. Okay, we have to move on. So if I asked you to change log base 4 of 18 into a different base, and I wanted it to be base 6, do it. Log base 4 of 18 written in base 6. I hope you start with log 18 over log 4, and what's wrong with that? Nothing's wrong with that, except it's base 10. And then, what do I do, Jacob?
Change the 10s to 6s.
Yeah, log base 6, log base 6. There we go. Log base 6 of 18 over log base 6 of 4. Okay, now that's one of several properties that you have to understand. This one I mentioned earlier. Remember me saying that this number could go out to the front? See how they did that? They just put it out in the front. When you have a log and you have a number here, you can just decide to put it there instead. There, done with that one. Now the last properties. These guys. They look really scary. Let me show you one of those in action. If you multiply, it goes with add. If you divide, it goes to subtract. That's the key. Okay, try to remember multiply and add go together. Doesn't multiply and add kind of go together already? If I have 6 plus 6 plus 6 plus 6, isn't that like 6 times something? You know what I'm saying? Okay, so multiply and add go together already. All right, so here's a typical question on this. Write this one down. Log base 3 of x plus log base 3 of 10 can be combined together into one log. Now you might think, who cares? Well, the reason that you want to get things down to just one log is here's a real typical scenario. It'll equal like 12. If I can combine this down into one log, then I can make an exponential out of it. Right now, there's no way to write this as an exponential, but if I could combine those two, then I can write an exponential, and I can say something to the power, and I can get the log out of there. All right, so how do I combine those two together? Did anybody with that super fast, like just a flash of seeing the formula, think you can do this? Give it a shot. Oh, wait. No, I'm asking this young lady right here. I'm not saying your voice because we're on your name because we're on the video. Go ahead. Log base 3. I agree. x times the 10 equals 12. And now why is this good? Because now I can rewrite it. Can you rewrite it?
So 3 to the
3 to the
12th
12th equals
10x.
10x. Perfect. And see how we're really close to solving it? We just have to divide by 10 and we'd be done. Whoa. That black one turned into this one, which I can just finish by dividing by 10. My answer is 3 to the 12th divided by 10. That is a typical tough ACT question. Requires you to know logs. What happened there? This turned into this, which was called condensing the log. And then once we're down to just one log, I can rewrite it. And this to the this equaled that. Circle of logs. Do you have a question? Or did I answer it already?
Oh, yeah. So like, what does the answer mean? 3 over 12 over 10. Is that like?
Good question. Remember to always go back to the original question. And the question is, what would need to go here? That's what x is. What would need to go here to make this work? We're just trying to figure out what needs to be there to make this equation really equal 12. All right, so condense again. You ready? Log base 4 of x minus, changing things a little bit, log base 4 of 5 is equal to 2. I'm going to pause for a second. I think you got enough info that you can do this.
X over 5.
Log base 4 of x over 5. Why did you do x over 5 instead of x times 5?
Because it's subtraction, so it's...
Because of that right there. Subtraction goes with dividing them like you just did here. Very good. Keep going.
Equals 2.
Equals 2. And then, whenever you're kind of stuck, think rewrite. Henry, can you rewrite this one for me? 4.
4 squared equals x over 5.
And isn't it almost solved?
Yeah. Then you can multiply both sides by 5.
Times 5 times 5. And it's solved. 5 times 4 squared. 4 squared is 16. 16 times 5. Okay. That's condensing. I don't know if you figured out this theme yet, but there's a lot of this in math. What if I gave you the answer? Could you go the other way and tell me what the question was? You could. You could say, well, if that's a divide, then it must have been a subtract in the first place. And it would have been log base 4 of x minus log base 4 of 5. And yeah. Okay, that's pretty easy because we just saw that one. And if you have any short-term memory, you'd probably remember that's kind of what it looked like. So let's try it when you don't know what's coming. This is the condensed version. What was it in the first place? Another way to say this is expand this all the way. Say it.
Log base 5 of x minus log base 5 of 7.
That's it. Good job. Okay, now I'm going to give you one where they always want you to expand but simplify. So, can this be simplified anymore? No. Can this be simplified anymore? No. So this one was done. But here's one where you have to expand it like you just did, which you've done well, and then simplify it. Log, which doesn't have a base. That means it does have a base. You just don't have it shown, of x over 10. Expand that and simplify it. My advice, whenever you see a log that doesn't have a base, it'll become all about the base. So go ahead and write that thing out. What is the base that's not shown? Base 10. And make sure you include that in your answer then. So this expands to log base 10 of x minus log base 10 of 10. And if you wrote it that way, I would cry a little bit and mark it wrong. Jacob, why?
You have to simplify it to 1.
That's 1. So it should have been log base 10 of x minus 1. That's expanded and simplified. Yes. Yes, you may.
Is the minus 1 on the exponential side, or is it on a normal?
So the way I would like to think of it is this. That is all one like little family.
Okay, and then so you were just subtracting the 1 from that entire thing, right?
Yep.
Okay, I wasn't sure. 'Cause
Now, I
it's
get
kinda
it.
high up
I
there.
get it. It's hard, kind of hard to tell if it's in the argument or if it's not in the argument, and it's not. Yes.
Do we have to write log 10 for these problems? Or?
No, but warning. I've said it like 3 times. Whenever there's no base, it's usually going to become all about that base number. See, if I didn't have that base number, I wouldn't have noticed this. See, the kid who does that goes like this. If they don't write the base out, they go log x minus log 10. And they don't notice that, oh crap, I should have written the base out. And I would have noticed that there was 2 10s. And I would have noticed that this was a 1. See what I mean? Okay, so let's do one more like that. ln of e over 4. I think I've taught you well enough to know that you would have immediately said, that's log base e, and then you know enough to go log base e of e minus log base e of 4, and then that's really 1. 1 minus log base e of 4. Raise your hand if you got that one. If not, look it through and try to figure out why. Yes? What?
Were you asking me?
Nope. Well, did you have your hand up?
Yes.
There was a question.
Yes.
Go ahead.
Can you rewrite it as ln 4 minus 1? Or does it have to be negative?
Is 1 minus 7 the same as 7 minus 1? That's fundamentally what you're confused about. Is 1 minus 7 the same as 7 minus 1? Does the order in which you subtract 2 things matter? Yes, it does. Because 1 minus 7 is negative 6. 7 minus 1 is regular 6. So there's a difference. So can you put the ln in front?
No.
No, you can't just say ln minus 1. That's not the same thing. Now, if you wanted to, you could say negative ln 4 plus 1. That'd be okay. Yes?
In the log base e and then the e divided by 4, is that, like you said, that equal to x?
You could set all of this equal to x if you wanted to. At the very beginning, you could say equals x. It just wouldn't help you to solve the problem. So you could, but you wouldn't want to. Okay. I think we need to, we've done a bunch of expanding. We've done a little bit of condensing. I think we're ready to actually look at some real hardcore problems. Okay, find the SpongeBob page here. And this is going to take a little effort. I want to remind you, remember this, that's to the 1/2 power. That's what square root really means, to the 1/2 power. Why does that matter? It matters. You can't just leave your answer with a square root of x in it. It matters because x to the 1/2 power, the power rule can come in where that can go down to the front. You remember that deal? That'll come into this problem. So go ahead, try this one. But don't forget that this x, a square root of x is x to the 1/2 power. Pausing. So I'm hoping you thought, oh, this is one of those kind where I can stretch it out into an add problem. Log base 2 of 8 plus log base 2 of y to the third plus log base 2 of x to the 1/2. Now, did anybody think maybe I should go further than that? Oh, nobody. Oh, Tyler thought maybe. What could you do that would go further than this?
You could use the log powers and expand it to log.
Wait, stop a second. And let's change a few things to help them see it. That 8 could be written as 2 to the what? And so now, where can that 3 go to expand this even further? Down to the front. So Tyler, read us the answer.
3 of log base 2.
Yep.
Plus 3 times log base 2 of y plus 1/2 log base 2 of x.
And I'm going to give you one last chance, Tyler. Look close. There's something else. Remember, it's expand and simplify.
You can simplify the 3 log 2 to just 3.
That's just 3 right there. There. You made it. That's about as hardcore as it gets. There's homework problems like that. Please practice this, or your next test will not go well. That's all I got for you for today.